Hey, welcome back to the channel, everyone. Last week, I published a new blog on my website, Editing Game Data at Runtime with Frida, and I wanted to create a YouTube video covering all the major portions of this blog post. So we're going to highlight what Frida is. We're going to review a very simple Android game written in Kotlin. We're going to review what that decompiled code would look like in something like Jadx-GUI. Then we're going to leverage Frida and a custom Frida script to modify some game data at runtime to effectively, quote unquote, beat a video game running in Android Studio. So this video is not going to cover setting up Android Studio or configuring Frida or anything like that. This is more of a use case video to see the power of what Frida can do and how you can use it on example projects. So without further ado, let's talk about what Frida is. So this is a dynamic instrumentation toolkit that lets you inspect and modify the behavior of a running application. And it works by injecting a JavaScript runtime into a target process, allowing you to edit game data or data of a particular application, modify its logic. I use it often on mobile pen testing to bypass security controls that would prevent me from leveraging rooted or jailbroken devices. So I'll use it to do jailbroken, rooted detection bypassing, or SSL pinning bypass, so I can leverage something like Burp Suite on a mobile application. Frida is an incredible tool that can do a lot. Let's actually hop over to Android Studio and let's take a look at what some Kotlin code looks like and what the game we're going to be modifying looks like. All right, so I'm inside Android Studio. I have a emulator pulled up on my right hand side, and let's take a look at what this game does. So it opens up and it's called Coin Quest. The object of the game is to collect 10 or more coins to win the game. We only have 8 available coins, so if we go ahead and click on collect coin, we are unable to collect any more coins, and if we try to claim victory, we're going to get a message, not enough coins, you have 8, we need 10 to win. What we want to do is use Frida to hook into that coin count and change it from whatever value it's set to 10 or greater so we can actually win the game. So this is an unwinnable game unless we leverage Frida. Let's take a look at the source code. So again, written in Kotlin, we have a private variable coin count. It's an integer that's set to 0. We have max coins available set to 8, which we can see in the user interface over here. We have to get 10 coins to win, and then we have some user interface logic here. We're going to hop over to these next few functions down here and describe these. So the collect coin function, if the coin count is less than the max coins available, coin count plus plus, so that variable that we have set up here that's set to 0, this will increment 1, and then it's going to update the user interface. And we can see this user interface function down here. And what this is just doing is it's updating the UI for us. And then if the coin count is greater than or equal to the max coins available, we're going to disable this collect coin button. And then finally, the check win function, if the coin count is greater than or equal to the coins to win, we display a message that you win, else not enough coins. So that's the logic behind this game. Now, in a more real-world situation, we're going to be leveraging something like Jadx-GUI and looking at an APK. So let's head over to Jadx and take a look at what the decompiled code looks like. So I'm inside Jadx-GUI, and I've dragged and dropped the CoinGame APK into the application, and I've gone into source code, com, example CoinGame, and where we were before was the main activity. I did not highlight that, so I wanted to mention that in here. We wanted to look into the main activity. This is going to become important when we're reviewing our Frida script. So really wanted to point that out. You can see a lot of overlapping here. The decompiler did a really good job. A lot of it makes sense, and this would be something that we can definitely reverse engineer if this was the only thing that we had available to us. We have the private integer coin count variable right here. The max coins available 8, and then the coins to win 10. We have the user interface implementation stuff all here, and then we have those two functions or methods if you want to go that route as well highlighted here. So collect coin, if this coin count is less than the max coins available, coin count plus plus, update the UI. So very similar, if not exactly the same. if this coin count is greater than or equal to this max coins available, we're going to disable that button. So we can make heads and tails of what's going on here, and then the check win. If this coin count is greater than or equal to this coins to win, then we're going to set the you win message right here. And then else you do not have enough coins. So this is what it would look like in a real world situation if we're editing a game or some application that we have permission to attack and mess with. We can definitely understand this and utilize a Frida script to do what we need to do. So our next step is let's actually look at that script and talk about what's going on in that code. All right, so I'm in Visual Studio now, and at the top, this is a real simplistic script. Java perform, this is going to wait for Frida's Java bridge to be ready before it runs any code. And then why we wanted to know about that main activity, because this is how we're going to hook into this. So java.choose. I want you to go to com example.coinGame and then the main activity. And we're going to pass in this instance in the onMatch function in here. So the java.choose has two functions it can use inside of it, onMatch and onComplete. Inside onMatch, we're passing that instance in here, and we're going to log to the terminal, found main activity instance, which is just going to let us know we were able to hook in successfully. Then we want to log what the current coin count is. So the instance that we pass into the function is going to be here. We're going to say, I need the coin count and what is its value. So we're going to log that to the terminal, and then what we're going to do is set that, and we'll set that to 50. So that's greater than 10. That should give us the win. And then we're just going to again log to the terminal the coin count set to, and now it should be set to 50. So if we were to run it right now at the current state of the game, since we got it to 8, it would say current count, coin count is 8, set to 50, coin count set to 50. This Java schedule on main thread instance update UI is going to update the UI of the game so that we can actually see that happen. If we didn't have this, the logic would still be set. This would still be 50, but it wouldn't be reflected on the screen. Finally, the onComplete just lets us know the script is completed and everything is ran. So a very, very simple script. Let's actually utilize this and finally leverage Frida in this example. So I'm on my terminal and I have access to my script, which is known as solve.js. This is what we saw in Visual Studio. And before I get too far ahead of myself, I have done an ADB root and started ADB bridges root, and then I shelled in, and then as I stated, I'm not going to show installing Frida, but this is the Frida server. This is what you need to include on your emulator, and you need to find the correct version that matches your Frida tools that you have installed locally. So on my machine, if I run Frida ps-tac version, I am currently at the time of this video 17.15.3. So that is the version of Frida Studio or Frida server I have here, along with the correct architecture for the emulator. So this is running in the background, so I can hook into Frida. What I can do is Frida ps-tac-GUI. This is going to hook into my emulator, and I need to get the process ID or the PID of the game. So I see coin example, com example coin game. These are all the running applications that I can interact with Frida, but we're interested in this. Now the next step is we are going to use that script. So Frida tac-l solve.js tac-p, and then this is 5127 tac-u com.example.coingame. Now if I hit enter, we can see Frida running. So there's the console.logs echoing out on the terminal. So found main activity instance. So good. It was able to successfully run. There's no issues with our script. It found the main activity. The coin count set to 8 because that's what it was set to before we incremented it or changed the value to 50, which now you can see in the UI here. And that's why we needed that update UI as well, because this would still be set at 8 if that wasn't in there. And then we have the script has completed. So now that we have 50, if we were to now click the claim victory, we win because we have successfully gone into where the memory of that game data is for that coin count and changed it from 8 to 50. So very simple example to show you just what Frida can do. I hope that you found some value in this. If you have questions, concerns, feel free to reach out. Don't forget that there is a blog post written up on my website, Jadx-GUI.com, if you want to read basically everything that I kind of highlighted in here. And if you, again, would like me to create content on setting up Frida, setting up Android Studio, setting up an emulator, please leave a comment below that you have interest in that so I can cater to my audience and create content that you would want to see. With that being said, that's all I have. Happy hacking and take care.